Hi, Algebra 2 students. This week we are going to begin our work of solving quadratic equations, and we're going to learn how to do this using a variety of methods. The first method we're going to use is by factoring and graphing. So hopefully you did your review this week and you're ready to keep factoring and applying that to solving quadratic equations. Let's start by talking about what is a solution to a quadratic equation. Okay, we call those the zeros. So the zeros of a quadratic, are the value of x that makes f of x 0. Okay, in other words, it's the x-intercepts. So x-intercepts and zeros, those two words go together. So I may use those interchangeably at times. Another word that we use in this context is roots. So when you're working with a quadratic function, you may be asked to find the roots. If you're working with a quadratic equation, you may be asked to find the zeros. So whether you're given an equation versus a function is what triggers that change in vocabulary. So either way, when you're asked to solve a quadratic, you are being asked to find the x-intercepts. Okay, and we know that the x-intercepts are some value of x, but they have a y value of 0. Okay, so these are real easy to find when you're given a graph. So let's look at these graphs here. So we're asked to find the zeros of each quadratic. Well, I can just see the zeros quite clearly here. I can see that the zeros of the first one, okay, or the x-intercepts, the first one would be -2. The other one is 2. Oh, I'm sorry, that's a -3. I miscounted, saying how simple it is, and then I do it wrong. All right, and 2. Next one, okay? This time, there's only one x-intercept, and that x is equal to 3. Finally, the last one, this graph never crosses the x-axis. There are none. You don't want to write 0 because if you wrote the number 0, okay, I would think that the x-intercept, the zeros, the roots, the solution is right there on the origin. But that's not the case. We need to write none. So as we're solving these quadratic equations, you may have an equation that you solve that has 2 solutions, like we see in the first example, 1 solution, or no solutions. And any of those are valid answers because we can see all of these are parabolas. Okay, so let's look at the steps we'll go through when we're solving these. The first thing we need to do is we need to replace the y with 0 or solve for y, okay? So we want to gather all of our x terms on one side, y on the other, and then we replace the y with 0 because we're looking for the x-intercepts. Y is 0. Once we have replaced the y with 0 and all of our other terms are on the other side, we are going to factor. Then what we will do is we will put our factored form equal to 0 and solve. Let's do a couple together, and then I'm going to ask you to try a couple on your own. Okay, first thing we do is we set this equal to 0. So I change my f of x or my y to be 0 equals x squared minus 4x minus 12. Now I'm going to factor my expression that's on the right. I'm going to ask myself what multiplies to -12 and adds to -4. I know I'm going to have a positive number and a negative number, and so their difference will be -4. The larger number will be negative. It's not 4 and 3, 6 and 2. -6 plus 2 is -4. Okay, so 0 equals x plus 2 and x minus 6. Remember, it doesn't matter what order I write those in. So now I have this rewritten in factored form. And we know, as the amazing algebra students we are, if you have a equation, okay, that is the only operation between the two terms is multiplication and the solution or the product is 0, one of these two has to be 0. It could be A is 0, B is 0. We don't know. Either one could work. So what we're going to do is set each of these parentheses equal to 0 and solve. So x in the first set of parentheses is -2. And now if I solve my second set, x minus 6 equals 0, x equals 6. So x can be -2, or x is -6, or I'm sorry, +6. Let's review the steps we went through. First, we set it equal to 0. Then we wrote it in factored form. And then we set each set of parentheses equal to 0, and we solved to get our final solution. Let's try one more together. All right, I set it equal to 0. Oops. Now this is a quadratic binomial. It is not a quadratic trinomial like we saw above. So there's nothing here in this C position. So what I'm going to have to do instead is I'm going to look at my two terms and look for their greatest common factor and factor that out. So I look at the numbers first, 3 and 18. 3 is a factor of both. I have an x squared here and an x there. I can factor x out of both terms. Now I divide to know what's left over, and the leftovers go in my parentheses. 3 divided by 3 is 1. I had x squared, I divided out an x, there's 1 x left. 18 divided by 3 is 6. I had 1 x, I divided it out, there are no x's left. So this is my factored form right here. I'm going to now use the same process as before, and I'm going to set each factor equal to 0. So 3x equals 0, x plus 6 equals 0, and solve. So x equals 0, and x equals -6. So even though I used a different factoring method, once I had it in factored form, I still set each part equal to 0, and I solved. I'd like you to try a bunch on your own. Really, that's the only way to get good at this. Notice all of these except for the first one are trinomials. So numbers 6, 7, 8, 9, 10, you'll solve like we did the first one. Number 5, you're going to solve by factoring using greatest common factor. So why don't you go ahead, pause the video at this time, and come back and check your solutions.